He was also a member of the FRC Faculty Research Committee in Engineering and Technology at Amity University. He has 17 plus years of experience in academics. Apart from his regular teaching, mentoring, and research guidance, he is actively involved with the academic and research world as an author of books, book chapters, and number of papers in reputed journals and conferences. He is a senior member of IEEE and ACM, life member of Indian Science Congress, and a member of other reputed societies like CSI India. He is associated with several journals, conferences, and technical workshops as a guest editor, reviewer, technical committee member, member of the publicity committee, session chair, and as an invited speaker. He has played an important role, including delivering keynote talks and invited talks, in participating in and organizing several successful academic and research-oriented events. Apart from providing research guidance and supervising PhD scholars, his name is included in the list of PhD examiners at several universities. His research area includes data science and its applications, knowledge representation, social computing, and graph theory. So, I request Professor Dr. Anirban Mitra to share his knowledge with all our participants.
So, good afternoon to all of you. Am I audible clearly, ma'am?
Yes, sir. You are absolutely audible. Please continue, sir.
Thank you, and thanks to such a elaborate introduction of the speaker, which I really felt a little awkward when I listened about myself. But apart from that, thank you very much, HIT. Thank you, ma'am. Thank you to all the organizer team for giving me this opportunity to share the dais, to interact, to deliver a talk, and to, in due course of time, to learn something from your end also. Thanks to all the audience here for expecting that they will be keeping a patience when I go on with the talk. If you have any question, please feel free to ask me. And if you have any question that comes in your mind after the talk, you may contact me over email or any other electronic mode. So with this, let me start my talk. So essentially, today starting at 4:30, right? So I'll be trying to deliver a talk of around 50 minutes. That comes around 5:20. And my area of work is knowledge graph and its mining. So in this talk, basically, I'll be giving or delivering a talk on a graph. Then we will go towards a knowledge graph. We will, discuss about various properties, characteristics, the definition of knowledge graph, and slowly and gradually we'll move on to certain examples. So starting with the graph, knowledge graph. So basically this knowledge graph, as you see, can consist of two words. Those are, one is the knowledge and one is the graph. Now, if you are from a computer science graduate, you must have read something called a topic called graph theory. So for them, this is a revision. For those FDP who has not attended any course of graph theory, or it is a part of discrete mathematics also, or you are from a non-computer science core background, then for them, I'm just giving you a little introductions. And my introductions will not be purely mathematical, but rather my introductions will be towards what we are going to discuss today. So, say for example, if I take an example of, just a minute. Yes. So let me take an example of myself. And the institute which is organizing this FDP, HIT. So I make a connection between these two. And in the connection, I tell that this is a connection, or this is what is the relation. So how does I am related to HIT? Most probably the relation may tends to I am related to HIT at this time as a speaker. So when we talk about the graph theory, we tell these tools as the node. This is node. And this line basically we tell us as edge or vertex. So we can define a graph G is equal to nothing but V comma E, where I can tell that V is two nodes, that is myself and HIT, and the E is that relationship we have established, that is a speaker relationship. So this is a graph. This is a different from the graph that usually we see in terms of like this, or a graph that usually we have in the machine learning. But this is a graph where we define it in terms of vertex and edge, and we call this type of concept as a graph from the graph theory. Graph theory. Now, there are when you talk about a graph theory, we have different relationships. For example, we can tell about connections as the roads between cities, say city A, B, C, D, and E. So we can tell A, B, C, D, E are cities. E are the cities, and the line that is, say, a line AB, or the line BC, or the line ED. These are the roads. So from this particular figure, we can say that there is a road between A to B, but there is no road between A to C. So we can say that from A to B, anybody can journey, anybody can walk, or anybody can travel. But from A to C, nobody can travel directly. They have to move to B, and then from B, they have to move to C. So what I mean to say in this particular figure is that, though it's a figure, but as we know, there is a very famous proverb that pictures tells 1,000 words. So in this figure, we can interpret a lot, and that what we are interpreting can be termed as a knowledge. For example, if a question has been asked that what are the cities if need to be covered if a person want to reach from A to E? Again, I'm telling what are the cities that a person need to cover if the person wants to start from A and wants to reach at E. So definitely the answer will be from A. If it starts, it had to cover B, it had to cover D, and then only it will reach E. So this is an example of a simple graph where A, B, C, D, E are nothing but the vertex sets, and A, B, B, C, and E, D, these are nothing but the edge set. Of course, we have not written all the edges here. Now, when we try to make some directions, in this particular figure, I am giving random directions, so don't bother about them. So now see, B to A, this direction shows B to A, it is possible. But A to B, it is not possible because the direction doesn't permit. So in such type of graph are known as directed graph. Directed graph. And when, if we remove the direction, say, we have another graph. We have another graph. And here I am putting a value, say 2, 3, this is X, Y, Z. I call this, since there is a value in every way, we call this as weight. We call this as weight. And we call this graph as weighted graph. weighted graph. So what we learned is that we learned about the simple graph, directed graph, and weighted graph. Now let us come back to what we have. So see, when we talk about, just a minute. So if I have a graph like this, if we have a graph like this, I'm arbitrarily drawing a graph. This is a graph G, comma V, comma E. Let me name them as A, B, C, D, E. Let me name the vertices as at 1, 2, 3, 4, 5, 6, and 7. So by definition, we can tell that G is G comma V that defines V as A comma B comma C comma D and E, and E defines 1 comma 2 comma 3 comma 4 comma 5 comma 6. So this is a simple graph. We don't have any direction. We don't have any weight factor. Now say this are just the names. These are not the weight factor. These are the names of the edges. Make it, please note it down. These are the names. These are not the weight factors. Now say suppose I can interpret this as E. E is a class monitor. E is a class monitor. And E has been given responsibility by the concerned faculty to distribute the note to all the other friends, that is the A, B, C, and D. So how or through which E could able to distribute the note? So see, E could able to distribute the note to A and D. Rather, D will distribute the note to C and or B, and A will also distribute the node to D or B. So similarly, in this connection, the node can be distributed to C. What I mean to say is that it's not important that how we are distributing or what is the optimization, but what we want or what we can easily interpret from this figure is that if I ask somebody that whether C has got the node that has been started from E or not, yes, C will get the note from B or C will get the note from D. C will get the note from D or C will get the note from B. So this is what? This is the knowledge or interpretation of graph. So going back to our thing, we have just studied about what is graph, and we know knowledge is no, it's about a facts and figure to assemble them properly. So a graph which gives us some information when we try to analyze them, that can be termed as knowledge. And when a graph is giving a certain type of information, find information, we call it knowledge graph. And what is mining? Mining means extractions of those knowledge from a graph. So with this, I just start my presentations. So now before I go into the definition of knowledge graph, just let me tell you another more important thing, that when we talk about a graph, that is a point A to a point B, there is a connection. This is placed in our data science. When we are handling the data, we know about a lot of characteristics. We know about a B certain number of characteristics. But this is what makes us important, because it tells us the relationship between A and being. Now see, I'll give you certain examples. So how the relationship is important if we look at certain things. So you can look at my screen. There is a picture. If you look carefully about this picture, you will see that these are the pictures of if we look at the heading, it will say that relationship types. So see, bibliographic network. This picture is known as the bibliographic network. So node types, we know by this time what is nodes: the paper, title, author, conference here. Relations types are pub where, pub year, and the title. So see into this, my dear audience. So there is a paper number 51. Now see how it is related. It has a pub year, www. It has a object. It doesn't have a direct object line. It is cited by paper number 61, and it has a L page author like this. So now, if my question is whether paper number 52 and paper number 51 has some kind of relation, paper number 52 or paper number 51 has some kind of relation, definitely yes. How? Because see, paper number 52 is cited by paper number 53, paper number 53 is cited by paper number 65, and paper number 65 is cited by paper number 51. So paper number 51 is a different characteristics, paper number 52 is a different characteristics. All are published by different authors, by different journals, maybe over the different year, but due to some, we can still establish a relationship, and that's the characteristics, or that's the advantage of knowledge graph, that it focuses on relationship and it focuses on establishing a relationship. This is one example. Another example, I'm going into live. So, dear audience, can you see my screen? There is a circular dots.
Yeah, sir.
Right. So,
Yes, sir.
okay. So this is an example of a knowledge graph, how it's real in real time, how the knowledge graph is used. So this is not built up by me. This is a World Economic Forum website. You can see the website here. Okay. Just I putting it on the screen to demonstrate the practical use of knowledge graph in establishing different topics. So say suppose I have a topic called artificial intelligence. Now artificial intelligence has some certain subdivisions. What are they? Say generative AI. These are the subdivisions of main topic artificial intelligence. So I'll put the mouse cursor and you can see this is a generative AI. This is another thing, bias and fairness of AI algorithm. This is AI and future of jobs. This is, can AI overcome its limitations? The geopolitical impact of AI, operationalization, responsible AI, AI diversity and inclusion, AI for the purpose. So see, the artificial intelligence is divided into this. So see, but this is not the theoretically what are the AI topic must content, but these are the studies that was made by World Economic Forum as per their relevancy. So in AI, they have put these terms to AI. Now see, I would like to know what are the jobs in AI. So accordingly, I'll try to prepare myself. I have read AI. So I'll go to this particular thing, AI and future jobs. See how knowledge graph makes a relationship. Clicking this, it has by clicking this, you can see there are certain black dots which has been highlighted. So what are those black dots? One is this media entertainment, you can see. Then another black dot is social protection. Another black dot is entrepreneurship, education, human rights, advanced manufacturing, industrial revolution, future works, mining and metals, and so forth and so on. Now see, I'm interested in media and entertainment. So I would like to know, as an AI expert, how in the job sector, media and entertainment can provide us more information. So simply I'll click this. Now see, hide this panel. So see, from there I went to media and entertainment. Okay, I have reached here, and from media I could search all the different types of jobs that media and AI can make. So see, if you see, there is an AI. Okay, I selected that. This is an AI, responsible direction of AI. So see, future works, artificial intelligence, arts and cultures, industrial values. So see, arts and culture. So this is where in media and entertainment, arts and cultures are there under the AI, and how one could able to select arts in kind of things in the job sector. So see, this is what is a real-time application of knowledge base and how it establishes the relationship between a distance nodes, how it establishes the relationship between a distance node and provide us the information or knowledge on the relationship. That is what a practical application of knowledge graph. Now let me go to my own slides and go with the traditional definitions and all. So we'll start with this. So, dear audience, is that PPT is available? I mean, it's visible at your end?
Yes, sir.
Right.
Yes, sir.
Thank you for confirmation, because I was changing the window from this to that, so that's what. So see, by definition, a knowledge graph is a structural representation of knowledge. So this is a structural representation of knowledge that incorporated entities, relationship, and the attributes. It organizes information in a way that machine can understand, enabling powerful data analysis and inference. So see, when I call about, but if I tell that this is the car and this is the owner, just see this graph. Just let me clear those things. Okay, so this is a node. It tells cars. This is a node which tells who drives, and this is a node tells the owner of the car. Owner. Now see, a car needs a driver. A car needs a owner. Now, what I mean to say is that every car is owned by someone and is driven by someone. So there must be a relation, because a driver could not drive a car which has no owner. A driver cannot drive a car which has no owner. So there is a relationship between the driver and the owner. This is a graph where three things are there. So see, car, driver, and owner. Now, is there any relationship between a driver and owner? Is there any relationship? There may be a relationship of, say, suppose hired. There may be a relationship of family. Okay. There may be a relationship of friends. Now, car and owner. So this is what is a knowledge graph. See, it's a structure. So this see, there may be a kind of car has its own attributes. This is an entity. This has its own attributes. Similarly, this is an entity. This has its own attributes. And this attributes is there, entity is there, and between this entity and this entity, there is a relationship. There is a relationship. So these three things, entities, relationship, and attributes, together makes a knowledge graph. And it is made in such a way that a machine, not only the human, because when the graph is too big, like social network graph, researcher's graph is too big that human cannot interpret, and the machine can able to understand and can able to interpret and able to generate knowledge. So that is about the knowledge graph. Now, definition why the knowledge graph is a semantic graph that captures knowledge in a machine readable format. So this is important. A machine could able to understand, read it. It consists of nodes representing entities, ages, representing relationship between them. We have just discussed it just now, a couple of minutes back. Forming them a rich interconnected network of information. Knowledge graph is the capture entities, types, and relationship. Nodes are entities. Nodes are labeled with types. Edges between two nodes are captured. relationship between them. So now, just now we have done an example of this car, owner, and driver. So if this is a relationship, drives, this is the ownership, that own, and this is the service provider. So from this graph, we know that the relationship is owns, drives, and service provides. So this is an example of the nodes, entities, and nodes capture relationship between entities. Now, there is a simple graph at the right side of the picture where you could say that E1, E3, and E2 are there. E1, E2 are nothing but attributes. E stands for entities, and R is nothing but relation. So these three together things makes the knowledge graph. So this is an example I was just telling, that node type, paper title, author, conference year, relation type, pub where, pub year, has title, has author, site. So from this is an example of knowledge graph from where even though two distinct paper, we could able to establish a relationship between two distinct paper written by two distinct author at different time. For example, if say suppose I would like to know a author A Balmin. This is a graph that has been obtained from the internet. It's not drawn by me. A Balmin is an author. A Balmin is related to M Sazia or not. These two authors are related anyway. Can we establish a relationship between them? So probably we will look into the graph and we will say that the A Balmin authored paper number 61. Paper number 61 was cited by paper number 65. Paper number 65 is cited by paper number 53, and paper number 53 was authored by M. So we can, though there is not a direct relationship of each other collaborating, but in due course of time, we know that M. Sazia and A. Balmi in the different time context, but they had a relationship if we look at the knowledge graph. Example of another knowledge graph, that is social network. So node type, account, song, post, food, channel, relation type, friends, like, cooks, watch, listen. So see, this is our just a minute. This is our point of traction from where we would like to get the knowledge. So there is a social network. We know that the person wants to listen, right? The person has a friend here. The person likes this. The person cooks the food. The person watches some Netflix movie. The person has another friend. So see, if we look at all the behavioral characteristics of that person over a knowledge graph, probably we would able to define the characteristics, the likeness of a particular entity. So if we look at the knowledge graph of this person, we would able to define the likeness or the characteristics of this particular entity. For example, we would able to define this as the friendship relation, Spotify as the music to be listened, wants to cook some certain dish, wants to watch Netflix. So this is one example of a knowledge graph that tells us, or that machine could able to characterize one human being with the help of knowledge graph. Example of Google knowledge graph. This is what Google is using in a real-time scenario. This is another real-time example. So see, if I say that this is an example of Da Vinci. Da Vinci, we know, is a great painter of Renaissance period, did a very remarkable painting known as Mona Lisa. So see, Da Vinci painted, this minute. Da Vinci painted Mona Lisa. Da Vinci is from Italy, and Da Vinci and Michelangelo are friends. Again, Michelangelo is a friend of another thing. So see, if we look at the Da Vinci as an entity, what we got? From this knowledge graph, we got what he painted, and this Mona Lisa is again been tagged by whoever the person. This is completely a different entities. Da Vinci belongs to Italy. Italy as a country is an entity. So, and again, there is another friend of Da Vinci called Michelangelo. Now, if you look at this graph, there is a connection. So from here, we can easily tell that Michelangelo was also related to Italy. It will be obviously, I'm not going to tell that Michelangelo belongs to Italy because there is no direct connection, but Michelangelo also, was related to Italy in some or other way. That's how the Google makes the relationships. So now that was, a real-time example of a knowledge graph, the definition of definition of knowledge graph. So let us go into a little bit deeper into the knowledge graphs topics. So property, the graph structure. Knowledge graphs are organized as graphs where nodes represent entities and edges represent relationship. Nothing new. We have been discussing this for quite a couple of last slides. Semantic richness. They encoded not only data but also the semantics of relationship between entities, providing context and meaning of information. So for example, when we call this as car, and when I go this and tells the owner, see, the relationship tells that owns. So this what? But if whenever I will tell it car and driver, the relationship from owns becomes the drive. So this is what is the semantics of relationship between entities, providing context and meaning to information. So what is the relationship between this and this relationship provides us information as how this entity is related to this one. Scalability, knowledge graphs can scale from sparse focused domain to vast interconnected data set. This is an example. This is an example of an interconnected vast data set. So knowledge graph machine can easily interpret. Then interpretability, the facilitate integration with other data sources and systems, fostering interpretability and data exchange. So this is an example of this last point, interpretability. So even from AI like things, we can easily go to air pollution. So knowledge graph help us to go into that air pollution. Then from air pollution, we can go into something called the digital economy. See, the digital economy. So what it is, the relationship that tries to establish, that provides us this type of relationship. So it facilitates integration with other data source and system. This is what is interpretability. Now going ahead, advantages of knowledge graph. Semantic understanding enables machine to understand and reason over complex relationship in data. Data integration integrates diverse data source, including structured and unstructured data, into unified knowledge representation. So see, when we talk about structured data, there are two types of data set usually we use when we talk about a web scraping. Structured data is the data that is usually in tabular form. That is, okay, we can put it on Excel format. And unstructured data is that is in a kind of website. So this is unstructured data. So see, what is happening is that when there is that kind of unstructured data and there is a kind of structured data, together I can bind them using the data integration concept, and knowledge graph provides us that facility. So knowledge graph provides a facility to bind unstructured and structured data. Query flexibility, support flexible querying for complex information retrieval, analysis and tasks. This we can easily determine that as if car owner driver. See, driver has a table, owner has a table, and the car has own characteristics table. Now, if I want to relate from driver to owner in a traditional, Oracle or SQL, we have to bring in the concept of primary key, secondary key, foreign key, and all those things. And accordingly, then only we can go and move into this. But when we have a graph like this, we can reduce the complexity and we can easily navigate from the driver things to owner things, and we can find out a relationship. This is an advantage of a knowledge graph, that it facilitates connection within data. And AI applications, powered with various AI applications such as question answering, recommendation system, and natural language. So what about the recommendation system? We all are been browsing YouTube. We know that if you browse YouTube for a specific type of videos, after a certain time, the YouTube starts showing us the same type of videos. So that is what is in behind recommendation system is going, and that's recommendation system use the knowledge graph to understand, we use the knowledge graph to understand the characteristics or likeness of a particular character. That is what we have described in this. So from this, if you have a listen to Spotify, a certain type of music, the recommendation engine provides the knowledge graph with certain kinds of input, and the same type of likeness goes on playing. Of course, with the system, everything has the limitations too. So when we talk about the limitations, so you have data quality. Knowledge graphs are dependent on quality and completeness of underlying data source. Scalability challenges. Managing large scale knowledge graph can pose scalability challenges, particularly in terms of storage and processing. Semantic ambiguity. Resolving semantic ambiguity and ensuring accurate representation of knowledge can be challenging. Maintenance overhead. Requires ongoing maintenance to keep the knowledge graph up to date and relevant. Privacy concern, integrating diverse data source may raise privacy and security. Now tell me, I'll just go into these all things. Data quality, knowledge graphs are depends on quality and completeness of underlying data source. So see, if you look at this particular things, there is a certain kind of limitations. What limitations? Say suppose this particular author doesn't even want to interact with any author here. Means in a remote sensing, they don't want to have a relationship with this. But a knowledge graph provides this relationship, number one. Number two is that there is no restriction or security barrier. From this, I can easily interpret that how this particular author is related to who all author. Say for example, I don't want to disclose who are the authors I am working on. But with the help of knowledge graph, a machine will able to tell me who, tell somebody else who is the author that are collaborating with me at this point of time. So these things comes as, okay, just a minute, advantage, limitations. Okay, so I've opened a two parallel window to crisscross easily. So data quality, as I told, it's dependent on quality and completeness of data. Scalability challenge, when I am in such a network, it is, and the network grows because this hardly represent very few authors. There are very few publications, but when I am taking into real time in numerous authors with numerous hands of publication, the network is very complex and very large, and the network is very complex and very large means we have the scalability challenge. Semantic ambiguity means that representations, that when I try to represent from a particular thing, say suppose how VLDB is associated with 2002, there may not be direct relation, because see, the directed graphs are showing a different things. Even there is no relation between VDLB and 2004. So these type of challenges occurs while we try to make a semantic things. Maintenance, when there is a big graph, there are the issues of maintenance. Privacy concern is that, as I just give an example that, a particular author doesn't want to let the people know who are the collaborator, but such type of graph is open and it provides an ample of information about a particular author and who is collaborating with whom. So there is a network issue, security issue. So these are the limitations. Privacy concern, followed by that knowledge graph in practice. So we just gave a few, discuss about the few examples. Knowledge, Google is handling knowledge graph known as Google Knowledge Graph. Amazon has its product recommendation. It uses Amazon product graph. Facebook's graph GPI, always Facebook comes up with the recommending who might be our friend, whom will be interested in. Similarly, IBM Watson is there, Microsoft Satoru is there, Project Handom, Room is there. LinkedIn is also now using knowledge graph to make us to recommend us whom we may be interested to connect and index. These are the various real-time system or companies that are using knowledge graph for under the recommendation system to give us a more accurate results. Application of knowledge graph, semantic search, enhancing search engines with semantic understanding for more relevant results. Recommendation systems, we have already discussed about it. Healthcare, supporting clinical decision making by integrating patient data and medical knowledge. So what happens is, medical knowledge is a different kinds of entity, and clinical data is again a different kind of entity. So this is what is happening is that they are integrating them. We are not, we are trying to avoid writing an SQL query where the two different entities are in a different domain. Rather than, we are trying to map them through knowledge graph so that the health supporting clinical decision can be taken. E-commerce, enabling personalized product recommendation and understanding the product relationship. So recommendation is still work as the backbone of the knowledge graph. Financing, facilitating risk analysis, fraud detection, and customer relationship management. This is done through a graph theory of communication. Message. Say for example, I just have a person is a graduate and he has taken a loan, he has not repaid it. So these are put in a weighted factor to find out how much what way financial decision can be taken. Smart cities, optimizing urban planning and resource management through integration diverse city data. So this is an example where we can use the directed graph or directed weighted graph to plan the city, that how much traffic flow or how much resource flow can be done from one direction to another direction. So these are the application of knowledge graph, serving informations. This is from the film, these things. I'll not go into detail with the constraints of time. So there are certain knowledge data graph databases there, because as companies are working in the knowledge, so publicly available knowledge graph databases are Freebase, Wikidata, DPDR, Yago, NIL. These are the commonly available public knowledge graph dataset. Common characteristics are massive, millions of nodes and edges are there. Incomplete, many true edges are missing. So see, you can see that giving a massive knowledge graph enumerating all possible facts is intactable. Can we predict pause but missing links? No, not yet. These are the examples of what we discussed. Now, coming to that, knowledge graph completion. So, given an enormous knowledge graph, can we complete the knowledge graph, predict missing relationship, links plus types? So see, this is a knowledge graph. This is of J.K. Rowling. So he is a movie guy. So he is associated with Stephen King. He is associated with C.L. Lewis. He has, has interest about making fantasy movies. Again, fantasy movies is made by Stephen King, is made by Tolkien, is made by C.L. Lewis. So see, Stephen King again makes a movie which is science fiction. So is there any chance that J.K. Rowling will be interested in science fiction movies? Probably yes, because J.K. Rowling is influenced by Stephen King, and Stephen King makes a scientific movie. So see, what will happen is that since there is an indirect relation in near future, there is a high possibility that J.K. Rowling, who is influenced by Stephen King, and Stephen King, who makes science fiction movie, J.K. Rowling will also attempt to make a science fiction movie. So this pink dotted line is the missing relation that can be predicted through knowledge graph. So link plus types. Going ahead, mathematical, when we talk about a representation, there are representation to notations, and representation to notation we also do for the knowledge graph. So for knowledge graph representation, we have triplets. H, R, T. So H is what? Head. R is what? Relation. T is what? Tail. So what is that? Say suppose if this is the graph H, T, and the line will be R. So we can tell that car owner owns So car is H, the owner is T, and the owns is R. So H, R, T. H is head, R is the relation, T is the tail. So this is how we represent a knowledge graph. The key idea is model entity the relationship embedded in the vector space given a true triplet HRT. Given a true triplet HRT, the goal is that embedding H and R should be close to
Sorry, sir.
embedding of T. Yes.
Sir, sorry to interrupt you. Can you please hide the last prompt on the screen? Can you please hide it? Because the last line is not visible on the slide.
Okay.
Yes. Thank you, sir.
Okay. So we are representing the knowledge graph in terms of notation H and R and T. So key idea is model entity relationship. So see, when we are representing them in HRT presentation, we can establish different relationship. What are the different relationship? We will be coming in next few slides. Given a true triplet HRT, the goal is to embed H and R. So we are using the H and R relationship between them should be close to the embedding of T. Now, exactly, I mean, forget about the mathematical notation. How to embed H and R, how to define the closeness. So when you talk about this particular line, okay, let me just in a layman's word, let me explain like this way. The same example I'm taking, car, and it tells that H and R. I have not gone through T. I'm just focusing into this one, H and R is owns. So when car is there, owns is there, definitely with this interpretation, we know that it will reach at the place called owner. So these two, if close enough, we can, reach to T. That is what in a non-mathematical language. Now, regarding different closeness, we are coming. So these are the algebraic relationship that we use to use when we are discussing the properties of knowledge graph with the reference to H, T, and R. Just a minute. Semantic relationship R H into T is R T to H. So this is kind of non-directed or simple graph. If I can move from this direction, I can move from this direction. Example, family roommate. So how A is a roommate of B, that implies B is also a roommate of A. Okay. Composition relationship R1 and R2 are 2, X to Y and R X to Z. That means that R X of Y. So see, say suppose we can tell that A is a friend of B and B is a friend of C. A friend of C. That means that this is I'm telling you, and A is a friend of B, B is a friend of C. It means that friendship R1 relation, because see R1 and R2 may be 2, but R1 relation X and Z. So A is a friend of C. So this is composition. Then 1 to n to 1. This is something like, see here relationship is not changing. Here H means see A is a friend of B, A is a friend of C, and dot 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 all are true. Example are the students of. Then we have translation intuition. Translation intuition tells that let's go into the example. For a triplet HRT or all the relationship with H plus R equal to T. This says that example Obama. So Obama, this is nationality. So that the same thing we try to drag. Let me have this translational intuition from the real-time graph. It will be easy to demonstrate. So here we have discussed we have discussed that Da Vinci is connected with Italy, and is Da Vinci is connected with Michelangelo. So from here we can see this graph, and we can tell that Michelangelo is also connected with Italy. Michelangelo is also connected with Italy because Da Vinci is connected with Italy, Da Vinci is connected with Michelangelo, so Michelangelo is also connected with Italy. So this is what, when it comes not connection but the combination of two, that Obama and nationality, we call it American. So it tells this one H plus R, this is H, this is R, this becomes equal to T. So this nationality of Obama becomes American. This is H plus R T. Next we have transit training, transitional institution for a triple HRT, H plus R equal to T. This we take some time to discuss. We will not go into that much of detail. Now link prediction using this Transi, who has won the Turing Award. See, a Q is on the Turing Award, and who is Canadian citizen? Q is a Canadian citizen. So see, from these two, we can make a prediction that the Turing Award was owned by a Canadian. From these two graphs, you can make a prediction that the link prediction. So what is the link here? Link prediction, if this is the Turing Award, and this is the Canada, since Turing Award is also owned by Q is also a Canadian, so Turing Award is owned by a Canadian. So this is what link prediction is there. Now we have composite, symmetrics, and all things that. Let us not go into all those details with the time constraints, because with this, a lot of algebraic notations will come. So with this topic today, link prediction, how you are making a link prediction using knowledge graph. So knowledge provides us, a graph provides us full of knowledge, and machine could able to understand it. This is what is a knowledge graph. And with this particular slides, I would like to take all of your permission to finish today's talk. It's around 50 minutes, exactly 5:20. So I'm presently stopping my delivering lecture at these slides, and now it is to you, all of you. Organizers.
Thank you so much, sir, for this incredible session. Now, I would like to ask the audience to ask their questions related to this session, or they can drop their query in the chat box as well. You can kindly ask, sir, your queries regarding today's session.
Hi, Anirban. Anjan here.
Good evening, sir. Tell.
Yeah, very good evening. Actually, in your example, this car driver and the owner. So if these two lines, this entity relations in diagrams, if these two lines converge into one line, then owner becomes the driver.
Right.
So my question is it not the false positive, or is it like a means closing in a single line where owners become the driver and driver become the owners? So there is either he is a driver or he is the owner. So is it not giving you the false positives?
No, sir. No, sir. It is safe. You are right, but knowledge graph doesn't give the false positive. Why I'm telling you, you are right, because we have taken an examples of a very simple one of a simple graph with 3 nodes and 3 connectivities. Okay. But when we talk about representing the knowledge graph, we have advanced version of graphs which consist of loops, parallel edges, weighted factor, and all things. So there, whatever query you have, we minimize them. And in case there is, because in case there is a situation when owner is a driver, there is a situation when the car is owned by the wife and drives by her husband. All these things can be reflected if the graph is drawn properly.
Okay.
So
all these
your
graphs will
query is
be
right, sir.
this,
But
all these graphs will be always this close-ended or the open-ended. Open-ended is also possible, right?
Right. We used to draw a complex graph, weighted, and complex graph, which is not simple with the loops and all things, self loop and all things, to describe this error factors. So your question is right, but we have not gone to that depth. It can be handled.
Okay, sir. Okay, for your kind explanation.
Thank you.
Yeah.
Thank you, sir. Now I would request Dr. Debasis Dal sir to ask his question regarding today's session. Sir, please continue with your query. Debasis Dal sir, am I audible? Okay, so let's move on to the another question.
Okay, so I need to read the questions. Can I see it somewhere?
Yes, sir.
No, is there any question? Then I'll read it.
Yes, sir. I'm waiting for that only. All the participants are requested, if there is any query, please drop it in the chat box, or you can directly ask sir as well. Okay, sir. So I think there is no more queries now.
Right.
So
Thank you.
sir, for today's inspiring and wonderful session.
Okay, so thank you, audience, thank you, organizing team, and the important persons and faculty members of HIT for these sessions and for giving me an opportunity to interact with all of you. So thank you very much.
Thank you, Professor Dr. Anirban Mitra, sir, for your valuable speech. Now, we are concluding today's session.
Sir, 1 minute, sir.
Yes,
Please. Can it use for the finding research gap? The knowledge graph can be used for finding research gap in the research process.
Knowledge graph can be
Is
used
there
for
any
searching.
possibility for that?
No, I didn't got the question, sir. Knowledge graph is used for searching.
For finding research gap for research persons. In literature,
Yes. If your searching is basically with respect to relationship, okay, with the established with the help of relationship, we could able to minimize the search gap.
I am telling about this. Any relation such as finding research gap in research. Is it research? These graphs can be used for finding the relationship between any process, such as machine learning algorithms used in several processes.
Yes, sir. Yes, sir. That is what I just shown you in the if you have attended the entire thing in earlier. I mean, in the first part of the lecture, I shown you a World Economic Forum where from artificial intelligence or from pollution we can move on to different research area, different research topic into that. So we can easily navigate to the areas using knowledge graph, sir. Yes, sir, we can.
I want to also note that any tool for finding research gaps, any tool for that review process, finding research gaps in finding any relationship in process of something like that. Any tool for that, such as. 824, something like that.
Okay, I'll work on it, sir. I'll let you know.
Okay, thanks, sir.
Okay, thank you, sir. Now, before concluding today's session, I would again like to ask all the participants, sir is available with us now. Do you have any query? You can directly ask sir. He is available with us.
So, ma'am, if anyone has any query, they can, drop a mail or through HIT or the organizer. So I'll be happy to answer them.
Okay, sir. Okay. Thank you so much, sir, for today's wonderful session.